Welcome guys, another 3U video. Mr. Lupos here from Beal. This is an exciting one, I think. This is a nice, efficient way to write something that you've been used to writing. So this is called functions and function notations. We already talked about functions, what they are last class, and now we're looking at function notation. And function notation is nothing really new. It's just a nice, clean way of doing something that you've done in the past. So for example, if I had an equation that said something like y is equal to 2x minus 4, and I said, hey, what's the value of y when x is equal to something? I don't know, let's say 3. You would go ahead and you would sub it in here and then work it out, and then you'd have y is equal to, well, what is that, 6? 2. And then you look at it and you go, oh, hold on, so y is 2. But the issue here kind of is, I look at it and I say y is 2, and you might have forgot what the question was. What is the question? I don't remember. Okay? And there's nothing here in the answer that tells you what the question is, but we're going to get around that. So let me just delete some of this stuff here. Exact same thing here. We're going to use something called function notation. So instead of writing y is equal to this, we're going to write f at x or f of x in its place. So it looks like that's a cursive f. So that's f, and then bracket x, close bracket. Okay. You can also use g of x, h of x, all these things. It doesn't matter. The f isn't anything special. Okay. And the g isn't anything special. H of x is another one. Sometimes we do this. We do f of x, and then we do f primed of x. So instead of doing, so the first one's f at x. The second one is f primed at x. Sometimes we go, the next one is an f double prime of x and that sort of thing. Now, one thing I want to mention to you, though, is it's a different way to write something. And it's a little bit, there's a way you could get confused, legitimately confused. And it looks like it says f times x. It's not. It's just a notation. It replaces y. There's nothing really new here. So if I want to know what what the y value, back up to this question here. If I want to know what's the y value when x is 3, I write it like this. F at 3 is equal to, and then I subbed in a 3 for x. So everywhere I see an x over here, I sub in a 3. And the nice thing about this is I'm going to get the exact same answer as before, but now I have f at 3 is equal to 2. So now in my answer, I know what the question was. My question was, what's the value of this function, or what's the y value of this equation when when x is 3? So right in there, you got the question. You got the answer, you got the question. Bam, bam, right beside each other, okay? So that's it. That's essentially, you already know how to do all this stuff, okay? If I said to you here, give me f at a half. Okay, that's the same as saying, hey, what's y? Write this exact same thing. What's y here when x is 3 or x is a half? You would just sub it in and find out what it was, right? And you do the same thing here. It's 2 times 1/2. You follow all your rules, your BEDMAS rules, and all that fun stuff, and you work your way through, and you figure out what the answer is. So 2 times a half is 1. Down here, it's 1/2 squared. That's a quarter minus 3. This gets a little confusing. So that is, let's use decimals here, 0.25 minus 3. So I end up with 1 over negative 2.75. And you can leave it like that, or you could figure out on the calculator whatever that is. Okay, so that's what 7, carry this. What's that? 4, 8, 11. What's that? 3/11. Once you flip this, negative 3/11. I think that's right. I'm not sure. No, 11/4 flipped. Anyway, I think that's right. Doesn't matter. 1 divided by 2.75. Put that in the calculator, and you get your answer. Is that right? No, it's bugging me. 4, 8. I think it's right. I'm not sure. Anyway, work it out. Okay, so other stuff you want to look at here. If you don't have an equation, but you have a ordered set of ordered pairs, like you have here with f. If I want to find out what f7 is, that's saying, hey, what is y when x is 7? So I go through here and I say, where's x7? Not there, not there. Oh, there it is. So what's y when x is 7? It's 8. So the answer is just 8. And here, what's y when x is 9, or negative 9, sorry. And you look over here and go, oh, it's right there. It's there. Okay. Here, you just sub this in. You go 2 times negative 5, subtract 3. Right? You can go ahead and do that. And then figure out what that is. Other things here, you want to work backwards. If if you look here, g of x is equal to 5, what's x? So that's really saying if y is equal to 5, what's x? So go back over here, and you would, oh, sorry, this is the equation. You go back here and say, if y is 5, what's my x? And I set it up like this, and I solve for x. So now I'm going to solve for x. 5 plus 3 is equal to 2x. 5 plus 3 is 8, divided by 2, x is 4. Okay, so you're working backwards here. You're finding your independent variable for that. Here, back to the ordered pair, if f at x is equal to 2 or y is equal to 2, what is x? So if that is 2, then my answer is -3. Okay, and you work your way through this, and there's more fun stuff there. Just one other thing I want to, we have some word problems here. There's one thing that comes up. It doesn't come up in the note, but it comes up later on. Is if I say, hey, g at x, just call it g at x, is equal to, I don't know, just make it, let's make it simple. 3x, that's it, okay? And I want to know what 2 of g at 1 is. Okay, and you look at this and you go, hold on a second, that looks a little confusing, it's a little different. All you want to do is it's asking what is double of g at 1. So we know that g at 1 is 3 times 1. Just sub straight in. G at 1 is equal to 3 then. Okay, 3 times 1 is 3. And if I want double that, all I do is I take my answer and I take it and I multiply it by 2 and I get 6. So 2g of 1 is double g of 1. Figure out what g of 1 is and move on. Okay, function notation, very efficient, very neat stuff. I'll show you here, for example, when we start doing word problems and that sort of thing, which we get to, it's nice to have this here, and then when you sub in, so for example, when you start putting numbers into the n value here, your question and your answer are side by side, and it keeps track of things a lot nicer. So really, you barely learned anything new today. Function notation, though, is going to be with you for the rest of this class and also for advanced functions if you take it. And that's it. Okay, enjoy. Any questions about this? If you don't get it, you will. Trust me, it's not that difficult. And any questions, come and see me at lunch. Take care.